Good evening and welcome to this Vocera by Riello fault finding webinar.
Obviously, we're working with Vocera components, Vocera boilers, but most boilers operate in the same manner and will use similar components. So this is fault finding. So here's a multimeter here. I try and encourage everyone to do as much testing as they can with the boiler turned off because you're simply safer. Infinity, there's absolutely no current or voltage passing between the two probes. Put them together, we should see zero resistance because there's nothing stopping the voltage from passing through the cling contacts and finding its way back to the meter. So that's showing us 10 kilo ohms, so 10,580 ohms. Air pressure switches, I have a couple here. These switches can sense 8 pascals. But if you must blow into them, blow across the top. And you could possibly hear that making and breaking, but the whole of your chest isn't going into that diaphragm. If there are any calcium buildup in there, and it could be much smaller than the one you can see on your right. So what I'd like to do now is show you the way our water block works. The movement of water that is sensed by the flow switch or flow turbine has fired the main heat exchanger up here. Pump has kicked in. The pump is bringing down the primary flow from the main heat exchanger down this tube past the, on this boiler, low pressure switch. The flow passes into this chamber here. The diverter valve here has pulled up a cartridge here. This is the heating flow, that is the heating return. It's pulled up a cartridge and that cartridge has blocked the heating return. So the primary flow from the main heat exchanger can't go to the radiators. What it does, it's a very lightly sprung non-return valve. So the pump pushes the flow through that non-return valve there into the plate, warming up the domestic water passing through the other side of alternate plates.
Do you advise any silicone grease on the cartridge bit, or is it just an attraction to dirt?
Now, if you had a new cartridge, you'd find it come in a Ziploc bag and it will be pre-greased. We spoke about testing motors with resistance. The actuator is a motor, so you can test it with one probe on the middle for the neutral. Test one side to the other. One on this side. I think this one is 800 ohms, so we're getting OL. So this is in the other position, so I'm going to go from the other side, middle to the other side. There we go. This is a gas valve off a current A rated boiler. These will be gas valves off a B rated boiler. Solenoid pair here, here and here. They are the solenoids that lift up the two plungers that allow gas to pass through. So they operate in a different way, but the solenoids are tested exactly the same way. They're the same solenoids. These are 240 volt or 230 volt solenoids. To test, use the meter set for resistance. Pin 1 to pin 3 will test EV2. Pin 3 to pin 4 will test EV1. Pin 1 to pin 3 should give you, oh, let's get that there, about 6.4, there we are, 6.4 kilo ohms. So that's good. EV2 is okay. From pin 3 to pin 4, about 0.8 or 800 ohms, 0.8 of a kilo ohm. Well, that's 0.9, that's in area, that's fine. So if we put a probe on here, this has got a resistance of 44 ohms. Most of ours will fall between 19, that's 19, and 70 ohms. All of the fans will have a resistance that you can relate to. They're the easy ones. The more tricky one is the latest style of fan. And this has two connections. I was told the easy way to check whether it's the fan or the board, put the boiler into standby, so there's no demand. And we've got two sets of connections. Pull the control wires out because they're low voltage. If the fan turns, it's the board. A few months after that, I did exactly what I've just done here. Pulled the wires out, fan turned, must be the board. So I ordered a new board, put the board in, same problem. I ordered a new fan, put the fan in, boiler worked. Took the new board out, put the old board back in, boiler worked. This is the culprit. So I had to take it apart and look. So buried in the rotor here, there are tiny magnets. They flash by this device here, which is part of the Hall effect sensor. This rotates, and as it spins, we're getting a series of blips coming back down to the board. So somewhere here, or maybe in this circuitry here, it's broken down. So the fan motor's okay, the Hall effect sensor had failed. That's fans. That just about wraps up testing components this evening.
From us all here at Vicara, from David, Margaret, myself, the team, thanks for joining us. We hope you found it informative. Stay safe, and we hope to see you again soon at one of our webinars. Thank you very much. Good evening.